Right, I'm going to show you how to differentiate a quotient, one thing divided by another. So if y equals u over v, where u equals u of x is some function and v equals v of x is another function, then y dash, which is the derivative, equals u v dash minus u dash v No, it isn't, is it? Okay, I'm going to show you how to differentiate a quotient, one thing divided by another, quotient. If I've got y equals u over v, where u equals u of x is some function and v equals v of x is another function, then y dash equals what? It equals u dash v minus u v dash over v squared. You can prove it quite easily, but it's quite a nice little formula, this u dash v minus u v dash. Sometimes you see it's v du dx minus u dv dx over v squared, which is easy to say, I guess, but you'll notice that this swaps the order of u and v round, which doesn't matter for regular functions. But if you start dealing with matrix stuff, then it starts to be a bit confusing. So I normally stick with this one. v du dx minus u dv dx. So y equals u v over v. Y dash equals v. Nope. U dash v minus u v dash over v squared. Nice little formula. Make the observation that if u is constant, what happens to this formula? Well, it's u dash, well, so in that case, if we've got y equals u over v, that means that y equals some constant over v. So, can we just have a look at this formula first? So we've got u dash v minus u v dash over v squared. But if I say that u dash is constant, if u is constant, so that means that u dash equals 0, because if u is a constant function, this just disappears. And then we get minus u v dash over v squared. So it's negative, you see, it's got a negative there. So what that says is that as v increases, y decreases because of this negative, if everything's positive, because of this negative term here, which kind of checks out. Okay, I'm going to give you one example and then I'm going to call it a day. I'm going to say y equals u over v, where u equals, let's say, sine x, and v equals x. So u over v equals sine x over x. That's called the sinc function. U over v equals that. So if y equals that, y dash equals, well, we'll just go through the formula. Here it is, u dash v minus u v dash. That's u and that's v. So what have we got? We've got u dash v. So what's u dash? That's cos x times v dash. Oh no, that is u dash. U dash v. Cos x times x minus sine x times v dash. So we're differentiating x with respect to x, which is just times 1 over v squared. So just writing out in a slightly more friendly notation, it's x cos x minus sine x over x squared. And there it is. That's how to differentiate. I'm going to give you one more example just because I can. Y equals u over v. In this case, u equals, let's say, x squared plus 4, and v equals, let's say, x cubed minus 3x. So we want to differentiate to u over v, which is x squared plus 4 over x cubed minus 3x. Well, let's have a look at this. Well, I just write down u and v there. So I've got my formula here. I'll write it out again. Where is it? Here it is. U dash v minus uv dash. Y dash equals u dash v minus uv dash over v squared, where u is this top here and v is that one there. So y dash equals u dash. So we just differentiate this one, so it's just 2x times v, x cubed minus 3x. That's u dash v minus u v dash. So u is x squared plus 4 times v dash. It's 3x squared minus 3 over v squared over x cubed minus 3x. So let's just, it's 1 over x cubed minus 3x times, what's this one? That's 2x to the 4. All I'm doing is multiplying out these brackets here. Minus 6, because 2 3 to 6, x squared minus x squared plus 4. So we'll do the x squared, that's going to be 3x to the 4 minus 3x squared for x squared times that term and x squared times that term, plus 12x squared minus 12. Oops, it's that squared, isn't it? So that should be squared. Okay, so it's x cubed minus 3x to the minus 2 times, see if we can do some simplification here. Well, actually, let's just do it one step at a time. 2x to the 4 minus 6x squared minus 3x4 minus 3x squared plus 12x squared minus 12. X cubed minus 3x to the minus 2. Now what's happening to that x to the power 4? We've got 2 minus 3, so it's minus x to the 4. So we've done that one and we've done this one. And x squared, so that we've got minus 6 minus 3 is minus 9, plus 12 is plus 3 x squared. So I've got that term, and that term. What have I got left? I've just got a 12. There you go, and there's my differential. I could write it out in slightly different form. Minus x to the 4 plus 3x squared minus 12 over x cubed minus 3x squared. Oh, there's a minus there. Okay, and there's my answer. So we use this nice little formula, just plug the numbers in and just get on with it. Okay, I'm going to stop there.